Alright, so this is Notes 6.2, and we are just going to explore some of the trends that you graphed out in Worksheet 6.2, where you kind of explored these relationships between the hare and the lynx, okay? So this famous predator and prey cycle that we see here, really this whole cycle was discovered, I believe, with these populations of the hare and the lynx. So, what you notice here is this really strange pattern, right? So we have here the hare is in green, and so you see it increasing, and then you see it decreasing again, and then you see it increasing, and then you see it decreasing, and then you see it increasing and then decreasing. And this happens continually. It's still happening today. So this was back in the 1900s, but we still record it today, and the same thing happens. Now, what's happening with the lynx population, you see that it's really low, and then it starts to rise, and it does the same exact thing, but it's after the hare population rises and falls. So the peaks here for the lynx always occur after the peaks for the hare. So that's a little weird. Why is that happening? Why do we see this kind of relationship here between these peaks, and what does it all mean? So we're going to explore these, and to do that, we're just going to kind of explore this little timeline down here. So this is a visualization of the graph that you did. So for your notes, you could either fill out the notes here, or you could also write these on the graph that you yourself drew out on your graph paper. But let's go ahead and look at these. So in 1900 to 1903, what was happening with the hare population? Well, when we look up at it, we see that it is, what is going on here? Sorry, you'll have to deal with my fingers touching everything on this. Alright, so you'll see that the hare population's increasing in 1900 to 1903. Okay, so here's 1900 and 1903, and we see the hare population is increasing. So why is it increasing? Well, the hare population is increasing because the hares are eating a lot of plant food. And as they're eating those plant resources, their population increases. So I'm going to say population here increases. You could also do an arrow there. So if you remember from the ecosystem food web, they have a lot of plant resources. So what happened? Our next question here is in 1903, we see that they reach a peak right here. So why did they reach that peak? Sorry. Oh my goodness. This is going to be frustrating, sorry. I'm grabbing the graph with everything on this one. Okay, sorry. So in 1903, we see that there is a peak happening, and we want to know why. Okay, so the reason is because they're really overexhausting their resources. I mean, so you have all these hares, they're having babies, you're having more hares, and all these hares are eating up these plants, and eventually the plant population is going to really decrease, and there's not going to be enough for all the hares to sustain that population, and so they reach a peak. And so here we say that, here, let's choose a slightly different color so that we can visualize this a bit differently. Okay, so the hares, they overexhaust, which means that they take too many resources. Okay, they overexhaust their food, and so because of that, there are less plants. So at this point, if we were to graph the plant population, sorry, let's just say plants, not points. If we were to graph the plant population, we would see the plant population decreasing right there as the hares are eating that. So that's happening in 1903. That's what we see happening there. Let's see. Yep, 1903. So the hares overexhaust the food. There's less plants, so they kind of reach this peak here. And what we see happening here is that they start decreasing. All right. Why do they start decreasing? Well, as the hares don't have enough food, they aren't going to breed that much. They aren't going to mate. They aren't going to have as many babies because, maybe they'll look for other food resources, maybe, but there might be some competition, and so that's really going to that's going to impede the population's ability to grow. Okay, so they actually start decreasing because the plants there might not be enough plants for them to continue to breed, and so as they just start dying, and even if babies are born, they might not have enough food. So as they start dying, we see the hares decrease. So here we can say the hares have less food. And what you'll notice here, and we'll get to this in a moment, but the lynxes are actually at an all-time high. So it's not very helpful. The lynxes are at an all-time high while the food is at an all-time low, which means you have these predators that are eating these hares. And so the hares have less food and more predators. And so we see a decrease in the population there. Okay, so that's happening right there. Let's change our color here. Let's go with blue. Okay, so let's look at 1906. Okay, 1906 is right here. What starts to happen to this hare population? Remember, we're in the green. Well, we start seeing it have a comeback. Why is it going to have a comeback? Well, plants, as they do, grow back. Okay, so the plants are growing back because they haven't had as many herbivores eating them. They haven't had as many hares eating them. So they're going to start growing back, and that means, hey, now there's more food. So the hares are going to start eating more. And so that's why we see in 1906 they start to increase again. We see them, though, at this exact year. The hares still hit a low point. And then as those plants are growing back, you have more food. Well, hey, that's great. Okay, so here, 1907 to 1913, we start seeing this increase again in the hare population. So we see the increase. And that's going to be really beneficial for the hares. So what the hares do is the hares eat more plants that grew back. And so that's why this is a cycle, because you see the plants going up and down. If we could draw the plants here, let's draw the plants. You see them increasing and decreasing while the hares are doing the opposite. So they're kind of doing this right here. Right? So that cycle is going to continue, because what we see happening again is those hares. Oh, bother. Someone help me. All right. Sorry. So these hares increase, and then they overexhaust their resources again, and so then they crash, and then the plants go back, and then they increase. Okay? So what's happening with the predators? Let's look down here. I color-coded this in orange. So in 1900 to 1904, what happens? Well, the lynxes increase. Okay, so the lynx population increases here. So my pen just stopped working. That's not good. So you'll give me a moment here. So the lynx are increasing, and why are they doing that? It's because they have more hares to eat. So the hare population is increasing, and that means your food is increasing. And so you're a lynx, you go out in your morning, and there you see more hares out and about, and that's because they've been eating a lot of food, and so they're starting to increase. Here we go. All right, so those lynxes are going to increase, and that's simply because their food, or the hares, increase. All right, what happens in 1904? Well, in 1904, the lynx reaches a peak. All right, so the lynx reaches a peak. And that's because what's happening when the lynx reaches that peak? Look at your graph. The lynx reaches a peak because the hares are decreasing, and so suddenly there's less hares to eat. And partially that's because of the lynx, so the lynx is overexhausting their resources because there's more lynxes. But also, it's because the hares themselves are overexhausting their resources. So we see less hares to eat, and so we start seeing the lynxes decreasing. Now, the lynxes are going to make a comeback, and so we see that here in the orange, and they make a comeback after the hares make a comeback. And the reason is because there are more hares to eat. All right, so keep in mind this is happening over a span of many years, and so a full cycle here is happening every 10 years about. And so the hares start increasing, and so then we're going to start seeing more lynxes. Okay, so let's do that. Now, so lynxes eat more. Now, the thing is, it's not just about eating, because if a lynx eats, that just makes, you might think, okay, that might make it bigger and might sustain it for a day, but what does that do to the population? Think about this. The more food there is, the more energy there's going to be in the lynx population, and the healthier they're going to be, and the more they're going to breed. Starving lynxes do not breed as much. If a female lynx does not have enough food, she's not going to breed, she's not going to have more babies, the population is not going to increase. The more food you have, though, the more likely the lynxes are to be in a healthy state to breed and to produce more. Even if they did breed, and if the ecosystem wasn't healthy and they bred, then if there wasn't enough food, the baby kittens would just die. And so you have to have enough food there for the population to increase. So the lynxes eat more and breed more, and that's an important part of this. All right, so that explains why we see this cycle, and this happens with a lot of different predators and preys. We see this in the population where we see the prey kind of preceding this rise and fall for the predator, rise and fall. As we look at this graph, there's an important word that I want us to examine, and that's carrying capacity. All right, carrying capacity, we can abbreviate that CC. It's basically the maximum size of a population that can be sustained in an ecosystem. All right, it's basically at what capacity can the ecosystem carry the population. Kind of like when you walk into a restaurant and they might say at the front, this restaurant has a capacity of 180 people, which means only 180 people can fit in there comfortably. Otherwise, they're not going to have enough food, they're not going to have enough seats, they're not going to have enough space for that many people. So ecosystems have the same thing. They have a carrying capacity. They can only sustain so many before a population would crash. So what's the carrying capacity of lynxes? Let's look up here. What's the maximum amount of lynxes that this population in Canada sustains? it kind of looks like it's right around 60, right? Everything's below that, and it's kind of in between that because you get 50 here. So for lynxes, I would say 50 to 60. All right. What about the carrying capacity of hares? Well, what we see here is that's a little higher, around 70 to 80. Okay, depending on the year. This year was a little bit lower. But for these years, it seems like it's 70 to 80. So we see 70 to 80 hares. And this is an abbreviation, remember. So it's not just 50 to 60. It's actually 50,000 to 60,000. Or 70,000 to 80,000. Because these are times 1,000. Okay. So actually, let's just write 70,000 to 80,000. Okay. So that's the carrying capacity. What do you notice about those carrying capacities? The hares are larger, right? So you have more prey and less predators. And that's kind of what we learned about in note 6.1. Each of those predators is going to need multiple hares to sustain itself. And each of those hares are going to need multiple plants to sustain themselves. So if we were to look at the biomass if we were to look at the carrying capacity of plants, do you think they'd be larger or smaller? Well, if it was like grass, you'd have a larger carrying capacity. Okay? Individual grass plants would be way larger than these. And so what you kind of see as you go down is a pyramid shape, right? So 50 to 60,000 lynxes, 70 to 80,000 hares, and maybe 100,000 grass plants to sustain those hares. And that's what we see in this ecosystem. Okay? And that affects the maximum value at which the hare or the lynx population rises. All right, let's look at this pyramid a little bit more in detail. So if we scroll down to the back page, we can look at this pyramid that shows us this ecosystem. Okay, so this is a pyramid where we can represent the food web. And you saw the food web in Jeez Louise, you're gonna hate me. Okay, so we saw the food web in the worksheet. Okay, so down here, what are these called? These are called the producers. Okay, they're all the autotrophs. And they do photosynthesis. Okay? So if we wanted to list some of the autotrophs that were inside that food web, if you look back at the food web, we saw things like forbs, which are like flowers, or grasses. We saw bog birch was something that the hares ate. Gray willow, that was something else that the hares ate. White spruce, so they kind of nibble on the leaves and the twigs of these trees. Soapberry is another type of plant that the hares eat. Okay, so those are the producers. What do we call the organisms that eat the producers? Herbivores or primary consumers. Here, let's change this to orange. Primary consumers. Those are going to be some heterotrophs, okay? So, what were some of those things that were eating those plants? We saw things like a red squirrel. We saw a spruce grouse. That's a type of bird. Okay, and we saw the snowshoe hare. That's our big one. Snowshoe hare. Alright, so a snowshoe hare, he's going to eat the soapberry along with these other ones, right? So let's just make it simple for each of them here. And the snowshoe hare is going to be eaten by Well, the lynx. Okay, and the lynx is what we would consider to be a secondary predator, or consumer. Secondary consumer. Okay, so the lynx is kind of at the top of the food chain is what we would say, right? And you have less energy up here, which is why we have a narrower top here. A lot of the energy is being lost as heat. And over on the side, what are we going to put on the side of this? Let's put decomposers, because they would get energy from all parts of the pyramid. And let's put detritivores. So if a lynx were to die, something's going to need to eat the meat or the bones or decompose those, and so the detritivores might, like an earthworm or some sort of fly might be on that carcass. If a snowshoe hare were to die, the same thing would happen. And so here, let's represent energy with arrows here. So energy would go there, energy would go there, and energy would also go there. So you have energy going in multiple directions, right? So there is, you can also have mushrooms growing on these trees here. So decomposers are getting energy from those things. Alright, so let's think about the ecosystem in terms of if we were to remove certain things. Kind of like Jenga. If you've ever played the game Jenga, it's like a tower. And if you remove just one block, sometimes it will collapse completely, but other times it might become unstable. An ecosystem operates in a very similar way. So let's kind of play around with these different ideas. What would happen if I removed the lynx from the ecosystem? Let's say that the lynx went extinct in this particular Canadian ecosystem. What would happen? Well, what would be the effect of the hares? Well, the snowshoe hare would probably really prosper, right? So they don't have any predators anymore. So the hares will prosper. They don't have any predators. They don't have any lynxes anymore eating them. But remember that food chain that we looked at? Okay, I'm going to pull up that worksheet here. This is a really complicated thing, right? Do other things eat the snowshoe hare? They do, right? So the snowshoe hare is eaten by the lynx, but we also see the snowshoe hare still being eaten by the coyote, or the great horned owl, or the goshawk. That's hard to say. Goshawk? It looks like it says ghost shock. I don't know. Alright, so red fox. Alright, so you got all these other predators still. So if we just removed one lynx, that might not totally make the hares totally prosper, but they would prosper more. The lynx is the primary predator. Okay. But hares still have other predators. Would anything else limit the population of hares from just exploding? Yeah, limited food. Okay, so they still have other predators and limited food. So if we removed the predators, or the lynx, they'd still be limited by the so very. Alright, so let's say as just kind of a summary that the hare population increases and the soapberries decrease. Alright, what if the hare went extinct? What effect would that have on the lynx? Well, the lynx would no longer have food from the snowshoe hare. Sorry, I just realized I moved my triangle. That's not good. Here, let's move this down to where it was before. Alright. So, can I move my screen? Stop keyboard. Thank you. Alright, so let's say that the hare went extinct. the lynx would have to switch to other prey, right? Because there still are other things that the lynx is eating. If we look back at our diagram, okay, let's highlight an orange, or let's do red. Okay, red, what is the lynx eating? The lynx is also eating this bird, the ptarmigan. It's also eating the grouse bird. It's eating the ground squirrel. It's eating the red squirrel. So the lynx will get energy from other things. But the lynx actually really likes the hare, and so if it doesn't get enough hares, the population will still decrease a little bit. Okay, so it might not be enough. So the lynx would switch to other prey. But, you know, that might not be enough. After all, the hare is a really populous organism inside of the ecosystem, and so you have a lot of these things. And so to get rid of those, you would not have as many squirrels as you would the hare. Though maybe after you got rid of the hare, maybe you would have more squirrels because there'd be less competition. Maybe. Who knows? All right, but in general, the lynx would decrease a little bit. The carrying capacity of the lynx would decrease. I mean, what would happen, though, to what the snowshoe hare was eating? If this guy went extinct, well, nobody would be eating the soap berries. At least the snowshoe hare wouldn't. So the soapberry population would increase. Okay, so the soapberries would increase. Now, let's remove the soapberries. What if we remove that from the Jenga tower of this ecosystem? Okay, let's choose blue. Alright, if the soapberry went extinct, you'd have less. Well, how would that affect the hares? You'd have less food, and so then the hares would decrease. The carrying capacity for the hares would decrease. And so what would less food for hares? Let's do that. Less food for hares. So the hares would have to find a new food source. New food source. Well, if the hares start eating something else, what if, like, squirrels really like this bog birch? Well, that's a problem, because now the hare might get into a fight with the squirrel. And so that's going to cause competition with other species. That's not necessarily going to be pretty. And so you're going to have more competition. You're going to have less food source. And so ultimately, the hare population is probably going to decrease. And if the hares are decreasing, how's that going to affect the lynxes? Well, the lynxes will also decrease. And you'd probably increase competition. Okay, so you remove the bottom, everything else will decrease. You remove the top, the middle would increase and the bottom would decrease. It's kind of weird. Alright, so those are just if specific species went extinct. And because of the nature of a food web being so complex, you can always switch to a different food, but that might decrease your carrying capacity a little bit. It might increase competition. Let's think about, what if we just removed all the secondary consumers together? What would happen? Well, if we removed all predators, think about the hares, okay? The hares would have 0 predators, so they'd have nothing keeping them at bay, except for food. So the hare population would really explode. And they wouldn't just increase a little bit, they'd increase a lot. They'd have nothing eating them. And what would happen is that they would actually overexhaust the food to a much more extreme degree than we normally see in nature. And so they would actually crash to a much more extreme degree. And so in nature, if we see something like this, if you remove the predators, you'd see something like this. Okay? So predators are actually beneficial because they prevent the prey from undergoing a population crash. Okay? So here what we would see is we'd see the hares would increase, and that would make the plants decrease, like the soapberry. And then ultimately that would cause the hares to dramatically decrease. Alright, what would happen if all primary consumers were removed? So that's like the snowshoe hare and his friends, the squirrel and the birds. What would happen to the secondary consumers? Well, they'd have no way to get energy. At least carnivores would, right? So carnivores, they can't eat plants. So that's super problematic. And so they wouldn't just decrease. The lynx would just kind of die. And then, how would this affect the food and the plants? Well, they'd have nothing eating them. So maybe they would skyrocket. Okay? So maybe you'd see the plants increase. Now keep in mind, this is very simplistic. And different things are at factor in an actual ecosystem. So every time a snowshoe hare eats a soapberry doesn't mean that the plant's going to go extinct or that it's going to die. Because usually when herbivores eat plants, they usually just eat a part of the plant. They don't kill the plant by eating it. But at the same time, they would still thrive a lot more if they didn't have any herbivores. And so, especially if these things are eating berries, that might affect different things because, the herbivores would be, they could be dispersing seeds, so maybe they'd be helping it, or they could also be damaging the reproduction. So, yeah, there's all sorts of different factors, but we're just going to focus kind of on a simplistic view of the ecosystem, and this will help us kind of predict what would happen. Okay, so what would happen if all the producers were removed? If we removed all the green things down here, what would happen? Well, there would be no ecosystem. And that's because you'd have no photosynthesis. So there's no way for the sun's energy to enter the ecosystem. So no way for sun's energy to enter. And so all the living things are either going to have to die or move and migrate somewhere else. Okay, so we haven't really discussed decomposers or detritivores, but what would happen if they were removed? If we removed like the mushrooms from the food web, what would happen? Well, the obvious thing would be that there'd be waste everywhere. So you'd probably have, dead bodies and bones and skeletons and meat that wasn't being decomposed. But another important thing that mushrooms do, and you might remember this from the nitrogen cycle, is they recycle nutrients. So without these, you would not have nutrients being recycled back into the ecosystem. And so if you had no decomposers or detritivores, your ecosystem would be very nutrient poor. So each of these parts of the trophic pyramid are important for the function of the other. So the lynxes here are important to keep the hares at bay and to keep these rabbits from overpopulating and crashing. And the soap berries and the producers are always necessary to get energy into the ecosystem to begin with. And we also see that the snowshoe hares are necessary for the lynxes to survive. So these are necessary for energy, these are necessary for the carnivores to survive, and these are necessary for the snowshoe hares to not crash. So when we talk about biodiversity and the importance of saving things from extinction, another benefit that a lot of you guys recognized was that there's an ecological role that we want to preserve by preserving a species. So yeah, those are the ideas behind how predators and prey kind of regulate each other and carrying capacity of an ecosystem, and how removing or adding different parts of the trophic pyramid affects the ecosystem. So those are notes 6.2.